Welcome to a lesson with Dr. Powell. Let's talk about what a sequence is. You can think of a sequence as simply being a list of things if we want, such as 2, 4, 6, 8, 10, and so forth. It could have an end or it could keep on going, just following a particular pattern. That's one way of thinking about it. But here's another way. What if we think of taking our positions in the list? Maybe this is the first position, the second position, the third, the fourth, the fifth, and so on. We'll call that X. We call this Y. This looks like a table of values, even a function where the input values, or the domain rather, are whole numbers. 1, 2, 3, 4, 5, and so forth. If we were to graph this, thinking of it that way, position 1, 2, 3, 4, 5, and so forth. So our Y value, 2, next one, 4, next one, 6, and so forth. It's as if these dots follow a graph. In fact, in this particular case, it looks like it follows the idea of y equals 2x. This type of sequence or list is called an arithmetic sequence. Sometimes I just like to think of it as a linear sequence instead. Linear meaning like straight line sequence even, or maybe just straight line sequence. This is a straight line sequence. And how do we get it? Well, look, between any 2 points, like this one and this one, let's find the slope. 4 minus 2 over 2 minus 1. That would be what? 2 over 1, a slope of 2. In fact, if we did between these two and those two, it would always be 2 between any of these. In particular, if you do adjacent ones, like 3 and 4, the run's always 1. So really the slope is just the difference between 2 successive entries here in this list. 6 and 8, the difference is 2. Hey, that's the slope. So our equation for our sequence then would be y equals 2x. However, when we write down y equals 2x, we're probably thinking about a line, a whole equation of a line where we can put anything in for x. What if we just want to put in whole numbers for x? Well, we use a different notation just to make sure we will. Instead of x, we'll use an n. And oftentimes for y, we kind of write f of x. So maybe we could write f of n. So this would look like f of n is equal to 2n. But we go a little bit further than that. Here, we say f of n is 2n. But to emphasize that the n is only going to be a whole number, we change the notation. So instead of n being in some parentheses, it's in the subscript. And we say, instead of f of n, we say f sub n, but it means the same thing. So we'll say f sub n when we read this part. Now, convention though for sequences, we don't usually use the letter f as we do for functions, but we can, and that's fine. This is a perfectly valid sequence notation. But standardly, we actually just start at the beginning of the alphabet. A sub n is often the notation that we might use. And so this right here is the formula that defines the pattern of this sequence, 2, 4, 6, 8. If we wanted to know what the 8th term of this sequence is, namely at position 8, we would just plug in 8 as the position. So plugging in is like putting it here. It's really like A of 8, but we rate 8 sub 8. And that's going to be equal to 2 times n, or 2 times 8 rather, because we replace n with 8. That's what that means. And we end up getting 16. Thanks for watching.